I'm going to have a recording for this session. Sharing. Can you see the document I'm sharing? Please let me know.
No, sir.
Even now you cannot see?
Yes, we see.
Okay, if you have seen the document, I want to proceed straight to discuss on memories. So at any given time, when we come across computer memories, what comes to your mind is the aspect about storage. All storage in a computer happens in a computer memory. And the way a memory device stores data in a computer is inside small sections known as cells. So any other time you come across an aspect about computer memory, understand that these memories are sectioned or sliced into small parts called cells. So this is where the data reside in a memory device. Whether you're talking about a flash disk, a flash drive, or whichever kind of memory. Now, since we've understood that in any other memory, it is sectioned into cells, you need to a little bit understand the functioning of these cells, or these cells are known as address locations, you see? So whatever the size of the memory, it will be having the comparable number of sections or cells in that regard. Now, for us to be able to compute the number of memory locations, I want to say that each location or cell has a unique address, which varies from 0 to memory size -1. At any given point, when you are coming across a memory, understand that it is actually having sectioning known as cells, which each of these cells is known as an address location. And for you to compute the number of address location, then you have to multiply and subtract memory size -1. For example, you are given 64K word. When I say 64K word, anything ranging from 8 to 96 bits forms something known as a computer word. For this case, a 64K word multiplied by 1024. 1024 is the standard that we'll be encountering. This is a standard for memories. So when I say 64K word multiplied by 1024, it gives you 65,536 memory locations. Remember I said that the number of address, or what we say memory locations, would be memory size -1. So 65,536 -1 gives you 65,535. Similar analogy is, for example, I have a memory of 0 to 9. Then it means that those are 10 address locations. That is why you see the aspect of subtracting 1, because memories range from address 0 to a certain number of address. So when it is 10, for example, 10 addresses, it means it ranges from 0 to 9. When I count from 0 to 9, I'll get 10 locations, you see, from 0 to 9. So that is the aspect of understanding. So when I say 64K word multiplied by 1024, I get 65,536 -1 to give me 65,535, which means that memory location moves from 0 to 65,535. That's important to take note of memories. Now, memories are primarily of 3 types: the cache memory, the primary memory, and the secondary memory. So I want us to quickly go through these 3 different types of memories. Now, the cache memory. Now, this cache memory, as it is a kind of memory found in between the CPU and the main memory. You see? Remember, I'm talking about 3 types of memories, but now this is a cache memory coming in between the CPU and the main memory, or the primary memory. You see? So it is in between. Now, this cache memory is a high-speed semiconductor memory, which speeds up the CPU. Remember, it says that it is acting as a buffer between the CPU and the main memory. It is a storage. Buffer is a kind of storage between the CPU and the main memory. Actually, it is holding those data and programs which are most frequently used by the CPU. So whatever is being used by CPU at any given time is held by the cache memory. So whatever is being processed by the CPU is held by this cache memory. And I said this cache memory is between the main memory and the CPU. At any given time, all those parts of data and programs that are needed to be accessed by the CPU are actually stored in the disk. But whenever needed to be accessed by the CPU, then the operating system transfers those data and programs from the disk to the cache memory, you see? So whatever has been stored in the secondary storage, for example, the data and programs stored in the secondary storage, such as a flash disk, the hard drive, and the others, or it is stored in the primary memory in that regard, and it is required to be accessed by the CPU, then it is the duty of operating system to transfer those data and programs from the disk to a cache memory where now the CPU can see it, or in that regard, can access it. So you can see how vital this kind of memory is very, very important. Now, the advantages of this cache memory, as we have said, it is made up of semiconductor materials, making it one of the first memories in that regard, consuming less time, but it's also storing the aspect of cache memories. It has a very small size in that regard, in terms of storage size. Again, it stores data temporarily, only at that time that is being used by the CPU. That is something to note. So you will read the others. Of course, the downside of it is expensive and smaller in size. So the primary memory, or what we would now say the main memory, is the second type of memory. Still, again, this memory is regarded as the working memory of the CPU, has limited capacity, and data is lost when power is switched off. So this is a kind of memory. If electricity goes off, already everything is lost. Examples of these primary memories, RAM and ROM. I'm sure you must have random access memory and read-only memory. We later on discuss that. So again, this type of memory is made up of semiconductor materials, but they are not as fast as registers. We have storage devices known as, or storage types known as registers inside the CPU. So still, again, this primary memory are not as fast as registers. So the data and instruction required to be processed, any data and instruction to be processed actually reside in this main memory. And we have said these include the RAM and the ROM. We will later on discuss RAM and ROM independently. So still, again, they are semiconductor materials. They are made up of semiconductor materials. They are usually volatile memories. You know what we mean by volatile. The volatility aspect comes in from the sense that when power goes off, it loses its content. So you have understood that cache memory is volatile, primary memory is also volatile. So you will read the other characteristics. The secondary memory, the last one, which is also known as the external memory. Remember, I said the primary memory or the main memory is volatile, but now secondary memory is non-volatile. You see, meaning that at any given time power is lost, then it is not losing its content. An example of this is a flash disk. And I want to agree with you that even if power goes off when I'm using a machine or a computer, whatever data stored inside my flash disk will not disappear. You see? Or any given time you're using your phone and power goes off in your phone, then whatever is stored in your memory card cannot get lost. We can agree with that because the kind of storage is non-volatile in that regard. So it is normally used for storing data and information permanently. Now, how does the CPU access the data stored inside these disks, or what we say the secondary storage? Now, the CPU accesses this data and information via I/O routines, or what we say input-output routines. So get the difference. When I was talking about the primary memory, or whatever is stored in the primary memory can be accessed by the CPU through the movement of those data and instructions by the operating system to where the CPU can access. But now when I'm talking about the secondary memory, the data inside the secondary memories can be accessed by the CPU via input-output routines. I hope you see the difference. Now, these secondary memories are normally magnetic and optical memories. They are normally backup memories. When I say backup, I mean it is a kind of storage where you can use for purposes of further access or later on access, because it is permanently stored. It can act as a backup memory. It is also non-volatile, and we have agreed that even if power goes off, it doesn't lose its content, storing data permanently, and many others. So you can read those. Now, I want to move deeper and discuss about random access memories and read-only memories. Now, random access memory, or RAM in that regard, is a kind of read-write memory, or what we see RW. Remember the introductory part of this course, we said examples of primary memory, or what we say in main memory, is the RAM and the ROM. Now, RAM itself is a read-write memory, as opposed to ROM, which is a read-only. You can only read, but you cannot change its contents. But the RAM, you can read and you can also change its contents. You see? Remember I said the RAM, as it is the working memory of the CPU. Now, again, this kind of a RAM is storing the data as long as the machine is in operation. So when the machine is switched off, all the data stored in the RAM is erased. Now, I want to say that, remember in the introductory part, I said that memories are sectioned into cells, storage locations known as cells. Now, I want to say that the access time of memory location 0 and memory location 65535, for example, is similar. So I want to say that even if it is location 65535, the time you access that cell is similar to when you are accessing location 0 or location 1 or 2. So access time is independent of locations. Most importantly, we want to agree that RAM is volatile, as we have introduced. The primary storage is volatile. That is why every other time you need a UPS, or what we say, uninterruptible power supply. Just in case there is disruption of power supply, then you can still continue running your machine or powering up your device so that it does not lose the contents of its RAM. That's why we need UPS next to your computer, so that when the power goes off accidentally, that UPS can still support you for some time. Now, RAM is generally small in terms of physical size and also the amount of data that it can hold. So remember, it is actually a device made up of semiconductor materials, and it is designed such that it can be able to be operated or to be a fast kind of memory. That is why it is smaller in size again, because of purely being made of semiconductor materials. So that facilitates, again, fast access. So anyway, RAM is small in size in terms of physical and also the amount of data it can store. Now, there are two types of RAM, the DRAM and the SRAM. And I want us to distinguish from the aspect of design, the designing aspect of it. Now, SRAM indicates that this is a static kind of memory, and it is storing content as long as power is being supplied. Now, SRAM itself is made up of 6 transistors and no capacitors. I hope you understand from physics the work of capacitors. that it stores charges. So with absence of capacitors in that regard, it means that this kind of RAM cannot be able to store these charges. So in general, I want you to understand from the design part of it that static RAM is made up of 6 transistors and no capacitors. Again, the working of it is that they don't need to be refreshed every other time. They are still faster and they are used as cache memories. They are large in size comparably compared to the other DRAM. They're expensive and also high power consumption. When I'm saying those aspects or characteristics, I'm talking about in respect to DRAM. That is it. So the DRAM on the other hand, unlike the SRAM, it needs to be continuously refreshed. That is the key difference. The other one you need to, this one you need to refresh continually. The other one you don't need to refresh. Now, that aspect of refreshing is you do refreshing using a refresh circuit. So the refresh circuit rewrites the data every other time. You see, that aspect of talking about refreshing is rewriting data. So the way you refresh the DRAM is by placing it in a refresh circuit, which rewrites the data several hundred times per second. So DRAM is used as system memory because it is cheap and also small. But when I'm saying cheap and small, I'm talking in comparison with the SRAM. Now, DRAM is made up of 1 capacitor and 1 transistor. Very important. You see, that's the difference with SRAM. SRAM is matrix of 6 transistors. DRAM is 1 capacitor and 1 transistor. So that is it about DRAM and SRAM. Now, I want you to be very keen on read-only memories because we have a range of read-only memories. Remember, as I introduced the RAM, I said it is a kind of read-write memory, meaning that you can change its contents or you can also read and you can also add new content. Now, the ROM on the other hand is read-only. Whatever is stored in the ROM cannot be changed. So it's a kind of memory where we can read, but you cannot write on it. So it is a kind of non-volatile. Get the word non-volatile. When we were talking about the RAM, we said it is volatile from the working aspect of it, that it is losing data when electricity goes off in that regard. So this one is non-volatile. It does not lose its data upon electricity disappearing. Now, this kind of a ROM is normally used by computers to store what is regarded as bootstrap instructions. The instructions required to start up your computer are known as bootstrap instructions and normally stored in a ROM chip. So this is the diagrammatic representation, a picture of a ROM chip. That is how it looks like. But it's also important for us to appreciate the different types of ROMs that we have. Remember, these ROM chips are normally found also in washing machines, the electric washing machines, the ovens, fridges, and the others normally have these ROM chips. It's very important. So we have a range of the ROM types of ROM. We have the MROM, the PROM, the EPROM, the EEPROM. So we want to distinguish these 4 types of ROMs. Now, the MROM, I would want to say these ones are the traditional kind of ROMs. The MROM, masked ROM. Now, these masked ROMs were actually made up of hardwired devices. Remember this in the introductory part of this, because I have said once and again that computers actually understand 1 and 0. Passive and active state. 1 to mean active state and 0 to mean passive state. That is what the computer understands. Now, MROM works in the analogy of hardwired devices, so that if I have a hardwired device, it means 1. If I don't have a hardwire, it means 0. I have another hardwire, it means 1. Another, no hardwire, 0, like that. So that at the end of the day, I'm making active, passive, or 1, 0, 1, 0, 1, 0. And that is how I get the instructions. So that is how a computer would understand the instructions. So MROM were first kinds of ROMs made up of hardwired devices. the masked ROM, so that when you have an hardware, it means an instruction, no hardware 0, another hardware instruction, no hardware 0, another hardware instruction. And that regard 10101, that is number 21. Okay, let me connect to power source. I think I'm okay connected. So I was talking about masked ROM, and we have agreed. So they are the traditional kind of ROM devices. Now the other hand is the PROM, programmable read-only memory. Now the working of PROM comes in from the aspect of fuses. If you have seen an electric fuse, if you are using a computer at the moment, you can see the plug that is connecting to a power source. Inside that plug, for your adapter, the electric charger. So you realize that that plug in the wall, inside it, there is a fuse. So that fuse is normally placed so that in case there is a power surge, then it does not burn the adapter, then it burns the fuse instead. So that is how the fuse is. So you must have seen a fuse before. So the PROM works on the aspect of a fuse, so that if you burn a fuse, then it means putting in instructions. So I buy a blank PROM from the market. This PROM is made up of fuses, so that if I have one complete fuse 1, I burn a fuse 0, complete fuse 1, burn fuse 0, complete fuse 1, like that. So you see, at the end of the day, I've created a pattern 1 0 1 0 1, which is equals to 21 in that regard. So that is an instruction in a computer. You see? So when you burn the fuses, then it is an instruction, putting in instructions. Now, the drawback of this one is that in case you burn accidentally or reprogram it wrongly, then it means you just throw away that PROM chip. It becomes useless because you have burned fuses and there is no way you can return it again. So wrongly burning the fuses, it means wrong programming in that regard, and your instructions cannot be erased, but throw away that PROM chip like that. So that is the working of programmable read-only memories. The other one is EEPROM. EEPROM and EEPROM. I want to explain erasable and programmable read-only memory, and electrically erasable and programmable read-only memory. Now, the working of EEPROM is that it works on the analogy of trapping an electric charge in an insulated gate region. So when I trap an insulated, that is an electric charge in an insulated gate region, it means an instruction. I don't trap an electric charge, 0. I trap an electric charge in an insulated gate region, it means 1, like that. So trapping an electric charge means putting in an instruction. So I trap an electric charge, it means 1. I don't trap 0, I trap 1. I don't trap 0, I trap 1. That is 1 0 1 0 1, meaning that is number 21. We will later on see much of this when we are going for the topic on number system. So that is the working of EEPROM and EEPROM, trapping an electric charge in an insulated gate region. The difference is that EEPROM, it gives you an opportunity to erase data. So that I have trapped an electric charge, but I want to change the data. Then I just expose it to UV light. But the other one, EEPROM, I erase electrically. That's the only difference. The other one is using UV light to erase the data trapped within the insulated gate region. This other one uses electricity to erase the data trapped in an insulated gate region. That is it. So you can read the EEPROM and EEPROM, and please be able to distinguish the two clearly. So that is it. Just to mention general advantages, is that volatile, they are non-volatile in nature. The ROMs are non-volatile because when the power goes off, it does not lose its instructions. Just like a computer. Computer cannot lose the bootstrap instruction required to start up a computer. It is stored in the ROM chip. So at any given time when you come and power up your computer, those instructions are still inside the ROM chip. So non-volatile in nature, they cannot be accidentally changed. They are cheaper than RAMs, easy to test, and more reliable than RAMs. So, you know, the reliability aspect is coming in from those, the nature of it, that it cannot lose its data easily, and the others. So this takes me to something known as a motherboard. Now, this, if you see this motherboard, this diagram, there are two particular slots here. These ones are the RAM slots. If you can see, this blue are highlighted. These are the RAM slots where you place now this RAM, the RAM chips. So depending on the type of computer, and I want to say that the motherboard serves as a single platform to connect all parts of a computer together. So all the components of a computer are actually residing on the motherboard. When you talk about hard drive, optical drive, sound cards, and many other things, all are connected to this motherboard. Now, again, you need to understand that these motherboards come from different manufacturers. And whenever I'm replacing components of a computer, I need to be cognizant of the manufacturer, whether it is Asus machine, whether it is an HP, then it means that the components need to be compliant with that manufacturer so that the RAM chip can be able to be able to fit within the slots, considering that different manufacturers have different configuration on how their devices or components appear so that it can fit within that particular machine. So you can read much on the motherboard, but you just need to understand a few aspects. So this motherboard is actually inside the case, whatever you regard as the CPU. So it is attached via screws, pre-drilled holes. So normally these motherboards contain ports to connect all the internal components. So whatever time you want to connect the internal component, you use ports. The next chapter will be discussing about these ports. So it provides a single socket for any other motherboard must provide a single socket for CPU, for memories, and normally one or more slots are available for in case you want to scale your machine. For example, I bought machine at 2 GB, I want it to be 4 GB or 6 GB. I just add the memory, the RAM chip. In that regard, you scale your machine like that. So you can read those other aspects. I want to discuss about memory units, measurement of memories. And I want to say, when I talk about measurement of memories, we distinguish between the low and the high storage units. Those are the kind of measurements we come in memories. So low storage units, we have a bit, the nibble, the byte, and the word. When I say a bit is a binary digit. Remember I said, and I've repeated, that a computer understands 0 and 1 only. They don't understand anything else. A computer or a PC understands 0 and 1. 0 represents a passive, and 1 represents an active state in that regard. In an electric circuit, in that regard, remember they are electronic devices. Whenever we introduce computer, we say these are electronic devices. So in that regard, the electric circuit or the working of a computer is in form of 1 and 0, which 0 represents a passive state, 1 an active state. So the smallest representation you can have or storage unit you can have is a bit, which is made up of 0 and 1. A nibble is a combination of 4 bits. When I bring in 4 bits, 0, 1, 0, 1, that is 4 bits. It forms a nibble. The other one is a byte. A byte is a combination of 8 bits. I bring in 8 bits, then it forms a byte. Then finally, a computer word is anything ranging from 8 to 96 bits would be classified as a computer word. So that is important. Now let's talk about the high storage units. These are the high storage representations, just like the normal measurements that we have in primary school. 1 kilometer is equals to how many meters, like that. So again, the same aspect about storage is that 1 KB is a combination of 1024 bytes. 1024 bytes, 1 KB. And you know what we mean by bytes. You see? Remember, I said to form 1 byte, you require 8 bits. And I want you to return back to where we were. We were doing computations, and I said 1024 is the standard we use in memories. I hope you're forming what is this 1024 now. 1024 is actually bytes, and you know what is bytes. Bytes is a combination of 8 bits. So 1 KB is 1024 bytes, 1 MB is 1024 KBs, like that. 1 terabyte is 1024 terabytes. I hope you have seen computers with 1 TB or 2 TBs in that regard, or 3 TBs in the market today. We have computers in configuration of terabytes. Servers, actually most of the servers work in form of PPs and TBs, terabytes and terabytes. So you need these conversions for purposes of doing computations in regard to number conversions, or what we say memory conversions in that regard. So you can be given convert 10 terabytes into terabytes. That it means that you must have this conversion to be able to do those computations. So understand it is very important. Okay, before I proceed, if there's any question, let me know before I proceed, because I don't want to move so fast, although I'm recording the session, just in case anyone misses or I move too fast. Now I want to explain about computer ports. When I say a port, I want you to take the same physical port that we have in Mombasa, in Kenya. The same port. It is similar to that, but now this is computer. So in an aspect of a PC, it is working on the same thing. The port at Mombasa is whereby the ship comes in, and this is where they can be offloaded. Things can be offloaded to the main. Yes. Those who are joining, please kindly mute. I think we are having good time until our friends have just joined in with a lot of noise. So we are talking about a port as a physical docking point where external devices are connected to the computer. That is where you connect external devices. You know these external devices like a mouse, a keyboard, and the others. All those ones are connected to a computer using computer ports. It would be either a programmatic docking point through which information flows from a computer, from a program to a computer, or over the internet. Sometimes they are programmatic docking point. For example, the way you communicate over internet is using computer, that is using ports, which are actually numbers in that regard. So like SSL is port number 443, for example. Those ones are programmatic docking point. Now, in this respect, I'm talking about physical docking point where external devices are connected to a computer. But you need to understand it can also be a programmatic docking point where information is flowing from a program to a computer or over the internet. Now, we have a range of ports which you need to understand. This diagram shows you a range of these ports. You see, there are a number of ports. One is the serial port, which is normally used for external modems and all computer mouse. So these ones are examples of these serial ports, the ones I have highlighted. The traditional kind of a mouse, which is being phased out today, uses pins, which was using pins, is actually being replaced by USB kind of mouse, supported mouse, as opposed to the other one, which was using serial port. So serial port at 9-pin and 25, it came in two versions, 9-pin and 25-pin model. Data travels at 115 kilobits per second. And I want you to understand when we're discussing about ports, be very keen on speed at which the data travels at that port, and also the configuration in terms of pins that it can support in that regard. So parallel port used for scanners and printers is also called printer port, comes in as 25-pin model. It is also known as IEEE 1284, the 1284 compliant Centronics port. What do I mean when I say IEEE 1284 compliant Centronics? IEEE is Institute of Electric and Electronic Engineering. It is a body governing the standards for electronic devices. That is why today, when you see the mobile phone manufactured recently, we have a similar charger. Previously, you realize that every other manufacturer would come in with its own type of charger for the individual mobile devices. But today, we are talking of a similar platform or a similar kind of charging device across the different manufacturers. This is guided by standards developed by Institute of Electric and Electronic Engineering so that we can have similar standards. So parallel port is also known as 1284 IEEE compliant Centronics port. So I hope we understand it, so that as we mentioned, you have understood. We have also PS2 port used for all computer keyboards and mouses, also known as mouse port. So it's also IEEE 1284 compliant Centronic port. There is also the USB, which you know. The USB was introduced in 1997, and most computers have 2 USB ports at minimum. Data travels at 12 megabits per second. Get marked out. Data is traveling in a USB port at 12 megabits per second. USB compliant devices can get power from USB port. I want to agree with you with that. Yeah. That if I want to charge my phone, I can use a USB port in any computer or any other device, even if it is whatever, a car or anything, so that from the USB port, I can charge my device. So USB compliant device can get power from a USB port. There is also the VGA port connecting monitors to computer video cards. It comes with 15 holes, similar to serial port connector, but serial port connector has pins, not holes. I hope that can be understood, the VGA port. So that normally some, in networks, soon the next chapter, we'll be talking about DTE and DCE cable, so that we have a female and a male cable. So when I say made up of a serial port connector as pins, and then the other one as holes, you understand what I mean. So the power connector comes in as a 3-pronged plug, which you know, where you get power source to your device. It's made up of 3-pronged plug. Even whatever you are using when you are charging your mobile phone, it is actually a 3-pronged plug where you connect to power. There is also the firewire port, a very, very important port. It is a technology by Apple. So inside this firewire port, data travels at 400 to 800 megabits per second. I think you have not seen any other port which can be able to transfer data at these very high speeds. And this explains why if you go to a broadcasting house today, you will be able to see Apple machines because of the criticality nature of data transfer in a broadcasting house, that you need to transfer data at very fast speeds. That is why they're using Apple machines, because of this technology of firewire port, which is very, very important. There is also the modem port, which you know what is a modem, connecting you to a telephone network. There is also the Ethernet port, which we'll also mention when you are coming into internet and networking, where the Ethernet port connects to a computer network or high-speed internet connection. So this port resides on the Ethernet card within your PC. Normally, data travels between 10 to 1,000 megabits per second, depending upon the network bandwidth of the source. You see, so depending on the source of internet, I want to say that Ethernet port allows data to travel between 10 to 1,000 megabits per second. There is also game port, DVI, and the others. You can read those ones, and also the circuits. So I would not want to talk about the hardware. We have talked about, you know what we mean by computer hardware, the input, whatever we discussed in our introductory course. the input, the output, the secondary storage, and the internal components. Now you understand what we mean by internal components: the CPU, the motherboard, the RAM, and the ROM. Just we discussed that. So you need to read on the hardware because we have covered that. So in the next class, I'll be interested to start on the software. I hope we are together at that. So I'll begin from software in the next session. So that is it. That is it.
Thank you, sir. Thank you, sir.